can see the screen. So I will be talking about cross-border rail transport potential. And basically the presentation will draw on a study we did in the European Union Agency for Railways. I think it's a year and a half ago it was published. The study is available on the website, and I will give a very quick overview of the main findings of the study, and then draw some conclusions. So I'll be relatively fast. You can see the study for further details. Maybe to start with, to highlight that the purpose of the study was to estimate and consider the growth potential of cross-border rail traffic, both passenger and freight, that would derive from a further removal of technical and operational barriers. So the focus is really on the kind of dimensions of cross-border rail transport linked to the agency's activities, be it in the area of technical specification for interoperability, so the technical side as well as also the safety side, but here we focus mostly on the interoperability side. And we give also some consideration to current and potential transport demand if those barriers are addressed, and then we draw some general conclusions on and possible recommendations. I think to highlight, it's important, apart from doing a literature review of existing studies on cross-border rail transport, we also looked into specific cases for freight and for passenger, 2 case studies for freight and 2 case studies for passenger. And then we also considered cross-border international high-speed rail. So I think that's all on that. So I think you have here on this slide, you have also the specific case studies, both for freight and for passenger. The case study for freight was the connection between Innsbruck and Brennerau. The second case study was the connection Giorgio Nord in Romania to Rus in Bulgaria, and the 2 passenger case studies were rail passenger connection between Vienna and Győr in Hungary and between Berlin and Kostrin. So those were the case studies that we considered. Maybe just to highlight before we go any further is, of course, cross-border, as was also mentioned in the beginning, is very important. There's some 30% of the EU population that are based in border regions, and there are some 2 million commuters that make cross-border connections every day. Not all by far by rail, but I think the idea here is to see how many of those and other trips can be transferred from other modes towards rail in order to address the climate change objectives. Okay, so then I will go to the main findings, very high level. I'll very briefly talk just a little bit of what we found out looking at those 4 case studies, but purely from a perspective of technical and operational issues, there is indeed a high potential for time savings at cross-border sections by solving the technical and operational issues. The study highlights that potential, and possible ways to move forward be further cleaning up of the national rules, and which are still, as also John Worth was mentioning, there's a need to move to a European orientation, to move towards full implementation and use of the TSIs, as well as also the further harmonization and the revision of the TSIs to address any remaining open points and reduction where possible of specific cases. So those are the main findings, there is a high potential. And if we are able to reduce travel time, both for passenger and freight, that's something that users, be it passengers or freight customers, will take into account in what mode they will choose when they decide on their trips. So those were the main findings. Just looking really briefly on the two freight case studies here. The first freight case study, as you saw, the one for Innsbruck-Brennerau, looking particularly on the cross-border section, Brennerau-Staatsgrenze. And what we found here was that there could conservatively be possible time savings of at least 50 minutes per train. And what you have in the slide here, the details is considered in the report, is what are the different technical operational barriers that could be addressed and then resulting in travel time savings. So 50 minutes for the first case study, and we can monetize that, and that's what is done in the slide, giving some annual cost for this particular cross-border section. For the second case study, the cross-border section between Giurgiu Nord in Romania and Rusa in Bulgaria. There we reach conservatively possible time savings of at least 6 hours. And you have again here the breakdown of the different travel time saving, travel time losses that could be addressed if some of these issues are addressed, like train braking rules, technical checks, etc. All these issues were identified in a EU study linked to the so-called issues logbook that looked into the barriers for rail transport from a technical and operational perspective. So that's all on that. Here for the freight cases, we were able to take a quantitative analysis with quantitative and monetized measures. When we go to the I still have something here on the, sorry for that. Some indication about how much does it actually matter if you remove the time losses due to technical and operational barriers. And this is based on looking at how sensitive demand is to travel time. And you get some on the y-axis, you have the rail freight travel time in hours, from going from 6 to 20 hours, and then of the y-axis you have then the potential change in demand, and you can really see that if you're able to, either in the case of the first case study, Austria, Italy, or the second case study, Romania, Bulgaria, you really have some substantial potential increases in demand. For the Romanian Bulgaria case study, you have something like 40, depending on the travel time, between 25 and 40% increase in travel demand. This is of course a rough estimation, a simple model, but it does indicate a potential that of course needs further validation. Then, as I mentioned, the passenger case studies. The first one was the Vienna-Győr in Hungary, and what we found there, just very briefly on that corridor, is there's no major pitfalls in terms of the connection. Demand continues to grow. We're talking about a journey time of between 70 to 115 minutes, but that could still be made by addressing technical operational barriers. You could still make some reductions in the travel time by around 10 to 15 minutes. In the second case study, we don't have figures. That's the one from Berlin to Kostrin. We did identify though some some obstacles for its further development, including legal and administrative procedures, technical issues in terms of availability of vehicles compatible with technical standards, and also practical obstacles linked to different languages. Then just very briefly on the high speed, of course, as also mentioned, they can be very competitive. At the European level, there are not that many cross-border high-speed rail services. Brussels Cologne is one, Brussels Amsterdam is another one. So this is one area also perhaps to develop further. And there are a lot of studies on this topic also referenced in the study. Now, so I will refer to for the details in the study. Very briefly, this is of course also important in terms of facilitating information exchange between the different stakeholders. Are the TSIs for telematics, for passenger and for freight, and in order to facilitate information between infrastructure managers, RUs, terminal operators, wagon keepers, in the case of freight, and in the case of passenger, to facilitate. You have the telematics application TSI for passenger was introduced to facilitate harmonization and standardization of procedures regarding data exchange between the multiple railway companies, passenger operators, and ticket vendors, as well as exchange between railway undertakings and infrastructure managers. That takes place at a harmonized level. What the slide says here was that implementation by opera vary, and in general implementation is progressing slow, but you have the details in the slide there about which functions have been progressed most in the case of TAF for telematics for freight, and you have here the details regarding the implementation progress for passenger. And this is something that we are monitoring on an annual basis. We publish a report on the website, and it's also something, these statistics is also included as part of the agency's general monitoring of the progress with safety and interoperability. We publish a biennial report. The next one will be published in June, and we'll also have an event 2nd of July. There's details on that on the agency's website. So you see here the limitations of the study, and I refer to the study for further details. This is a first study on this issue, and it's something we could foresee to go further into, maybe to look at other case studies, and maybe just to draw some conclusions, because I'm aware of the time. Although the interoperability of the EU rail system is improving in recent years, technical and operational barriers at cross borders still hamper the seamlessness of international rail connection. This study focused on the possible reductions in time by solving the technical and operational issues on selected cross-border sections, showing a high potential. And I think this is what should be emphasized, potential. The reduction in travel time could contribute to improve competitiveness. And based on our findings, there's a particular need to emphasize further cleaning up of national rules to move to a European perspective, and to the role that the technical specification for interoperability can play regarding contributing to lowering some of the barriers by closing open points and reducing, where appropriate, specific cases. So I think in conclusion, there is a potential for modal shift. A strong and modal shift is indeed possible. This will involve all stakeholders, be it at local, regional, national, and European level, as well as across modes, so multimodality is also important. And what would be needed here is a range of measures, not a single measure to address and promote the modal shift, but a range of measures. Thank you very much.